Hi, I'm Sunip Mukherjee, and I want to talk about characterization of the upper atmosphere using faint emissions from a high-altitude balloon. In the picture, we can see the gondola on which Picture C, the primary instrument, rides. The arrows point to COMIC, or the Compact Multichannel Imaging Camera, contained in a 4-inch cube, and its battery pack on the gondola. Here we can see the balloon launching and flying away on 28 September 2022 at 8 a.m. Now we shall focus on what COMIC observes. We see here that COMIC sees different parts of the scene in different wavelengths as labeled. The plot at the bottom follows the change of the instrument temperature with time. The local clock time of each frame and altitude are listed at the top. We follow the launch crew as they prepare, launching at 8 a.m. local. We ascend to about 39 kilometers by 10:50 a.m. local. During daytime, the reflected light from the Earth is too bright and the detector cannot measure faint emissions. Around 1:30 p.m., COMIC is in the shadow of the sun and the instrument cools off before warming up to 60 degrees Celsius. The sun crosses the scene before sunset. Between 6:48 p.m. and 7:10 p.m., the day-night terminator approaches the location of the balloon from the east. The ambient emission brightness is at least 2 orders of magnitude brighter on the day side of the terminator compared to the night side. At 7:36 p.m., COMIC observes the first stars. In 780 nanometer and 560 nanometer sections, horizontal bright and dark patches are present in the background that appear to rise and set vertically, following the stars and the rotation of the Earth. At 36 kilometer altitude, no clouds are present. The 780 nanometer and 560 nanometer filters cover 10 nanometer bandwidth and are capable of observing faint emissions from the ionosphere at 777.4 nanometers and 557.7 nanometer wavelengths. The observed variations are caused by the distribution of these emissions. 557.7 nanometer emissions are seen to have similar variations from ground-based measurements. At 2:28 a.m., the balloon is popped and the instrument returns to the ground by 3:19 a.m. These observations prove that COMIC can be used for remote sensing of the ionosphere by using these characteristic emissions. Thank you.